ครับท่านผู้ชมวันนี้รายการโยธาน่ารู้นำท่านมาพบกับแขกชาวต่างประเทศนะครับวันนี้เราจะพบกับมิสเตอร์โรแลนด์ เชลเลนเบอร์เกอร์ซึ่งจะมาให้ข้อมูลเราเกี่ยวกับเรื่องของจะเรียกว่าเป็นอิฐมวลเบาก็ได้นะครับแต่ว่าเขาจะเรียกว่าเป็น Autoclaved aerated concrete แต่ผมก็ไม่แน่ใจนะครับว่าในความรู้สึกของเราเนี่ยมันมีความแตกต่างจากอิฐมวลเบาอย่างไรก็จะให้คุณโรแลนด์เล่าให้เราฟังนะครับนะว่าไอ้ตัวผลิตภัณฑ์นี้เนี่ยมีที่มาที่ไปอย่างไรมีข้อดีข้อเด่นอย่างไรนะครับเมื่อเทียบกับการใช้อิฐที่เราใช้กันอยู่ในประเทศไทยนะครับ The first question is because I think we talked before about the autoclaved aerated concrete or in short we call AAC. What is AAC then?
AAC, or like you say, It Muon Bao, is a long-time existing construction material. It was designed first time in 1924, and since many years it's also used and manufactured in Thailand. You have several companies making AAC blocks, and from my point of view, AAC in Asia and Thailand is not yet used to its full potential. So it is a very versatile construction material. It shows a lot of advantages when you are using it, and it has a very wide range of product applications. So you can have a block in different sizes and different densities and compressive strengths. You can have panels, reinforced, non-reinforced. You can make an ultra-light, slim panel as a cover for existing walls in order to use for fire protection or thermal insulation. And the new way of construction regulations, from my point of view, will make the right or the perfect use of AAC mandatory in the future.
If we compare the AAC with the local brick that we have in Thailand, we have the red brick, the clay that we heat it, and make it strong, and also we have concrete, we call the concrete block, the concrete block, but it's quite heavy. But if we compare to that kind of local brick that we have, what is the advantage or disadvantage when you compare to this kind of brick?
If you compare block by block, the AAC blocks can be manufactured with a very high dimensional accuracy. We use normally AAC glue or foam to connect the blocks to each other. And because of its very high compressive strength and density, we can use AAC blocks as a load-bearing wall. So if you have the right width for the blocks, you don't need columns and beams. You can reduce construction time of a, let's say, family house by 50%. You can reduce steel, metal by up to 80%, which reduce a lot of cost and time in the factor. And then you can build a wall which is already very smooth due to dimensional accuracy. So you only need a very thin layer of fluster finishing to make the wall complete. You have a very good thermal insulation, so hot air will stay outside.
And permeability.
Exactly.
During the raining season, it has a splash of the rain. It will not seep through the wall into inside the house.
AAC is not soaking in water. You will have the outside a little bit wet, which will dry fast again, and the core of the AAC will stay dry. And this is also one of the advantages of AAC.
No, I think it's dependent on the thickness of the block also. If we have a slim one, maybe the water can seep through and get inside the house.
Let's say maybe it's a few millimeters of the outside which can get wet. So the slimmer the block is, the more of the block will be wet. But compared construction ways in, let's say, Europe and in Asia, we have a block of 35 centimeter width or 25 centimeter width minimum. And there, from the experience, this is absolutely okay.
And how about the erodibility? Because for the AAC, it's easy to do some like block out, and I think you can scrap with the metal.
Yeah.
And I'm afraid that about the erodibility of the AAC. Once the life of the building is get older, is maybe the erodibility will have a problem with this kind of material.
Yeah. So normally, as far as I know, in Thailand also, most of the buildings have outside protection.
Yeah, we do plastering.
Plastering inside, outside, so the stone itself is protected.
It's well protected, but for AAC, you said no need to do some plastering.
It's a very thin plastering on the inside. So to make a smooth wall on the inside, the plastering is very thin. But you still normally make a plastering because you have this porous surface of the AAC. For example, in Korea, Korean architects like the natural buildings, metal and stone combined, and they very often do not make any treatment of the outside.
I see.
So they just have a pure stone wall and the metal connections with it. But here in Thailand, the normal way of making the house is to make a plaster on the outside, the same like in Europe, and also in the inside to have a smooth wall which you can paint or can put a tapestry on. This plastering is there to protect it. AAC looks very weak. If you manufacture AAC, you have several ingredients, raw materials which you mix together. So it's sand, it's lime, cement, gypsum, and aluminium powder or paste. The aluminium powder will create a hydrogen gas, which will let the whole cake in the mold rise and get bigger. So you have 85% of air inside the AAC. And the sand, the silicium dioxide and the calcium oxide from the sand and the cement will create to a turbomerite. And you will see the picture where the structure on the microscope is shown. And this, like a beehive-like texture, is making the stone itself very strong. For sure, if you would grind it, it's easily going away. But generally, the blocks are very strong.
And in terms of fire protection?
Yeah. It's all natural ingredients, and we have tests saying up to 180 minutes that the stone will not have any interference with the fire. So it will not start to burn, and the surface will may crystalline a little bit, melt a little bit, but the stone itself is normally in a fire protected way. And there were fires in America where all the wooden built houses were burnt down, and the AAC built houses were still standing. The same with earthquakes, like the earthquake in Turkey, where the houses built with AAC were the strongest one to still stand after the earthquake.
No crack at all?
Damages depends always on the strength of the earthquake. Some small cracks maybe, but the house itself was still okay that people could still live in it. So structural damages from other houses, as I said, okay, the static is no longer okay. This did not happen.
Okay. And about the time consuming, when we compare with the normal brick that we have and the AAC, which one is faster?
Definitely the AAC. We have normally bigger blocks. The blocks are matching perfectly on each other. So we have just a little thin layer of glue to put on, and then we just lay one block on the other. If we have tongue and groove, which a modern factory can grind into the blocks, even the straight way of making the wall is already given from the tongue and grooves. We can have handles to carry the blocks easier, which a modern factory can also grind into the block while manufacturing it. And because of the size, because of the dimensional accuracy, the manufacturing of a wall, the erection of a wall is much faster.
And about the insulation, it's better than the concrete block that we have because we have a hollow core inside and big hollow core.
Yeah. It is said the best insulation for temperature and even sound is standing air. Moving air is carrying everything, but if the air is standing, it's the best insulation you can have. In Europe, we sometimes build, or we very often build a row of blocks, 10-20 centimeter gap, and another row of blocks. So the walls are getting very thick in order to be very environmental friendly for heating and cooling down the house during the different seasons. And the standing air between the two rows of blocks is the best insulation. AAC is consisting 80%, 85% of air. So the air standing inside the block is protecting the heat exchange of the material in a very good way. And there are tests that the outside temperature have been changed from 10 to 80 degrees, and inside the temperature changed by 1 to 2 degrees. So even a very huge change on the outside temperature, inside at the 240 millimeter wide wall, the temperature only changed by 2 degrees. So it's a very environmental friendly and energy saving for cooling down aircon cost related construction material.
Then how about the cost then? The cost of AAC per square meter compared to the brick that we use in Thailand? Because I think for Thai people, we are also aware of the cost of the material. But I think this kind of material the cost is higher than the red brick that we use or the concrete block that we use.
On the first view, yes. If you just take a red brick and a AAC brick, the cost compared brick by brick, I would guess the red brick is cheaper, easier to manufacture. You don't have the autoclave running for 12 hours with 200 degrees and handmade. If you look on the whole construction, the construction time, with a red clay brick you cannot make a load-bearing wall. So you need columns and beams. You have a lot of metal you have to put in. It takes time to make the metal mesh. Then you have to make the mold to fill in the concrete. This has to be hardened. So the whole frame of the house with the column and beam frame takes a lot of time of construction. Saving 50% of the construction time for several workers per day is already a very high factor of savings. The second point is the material cost. Saving the metal from the columns and beam structure can save you a lot of money. If you then compare a one house, 200 square meter living area, 2 floors, so and so many red clay bricks, so and so many AAC blocks, columns, beams, metal, working time. If you put all this together, the AAC is definitely cheaper.
And you said we can build the house without column and beam by use this kind of block.
Yeah.
How high it is we can build? Because for the 1-story housing it's okay. 2 stories maybe it's okay.
It's okay.
If we want to build like 8 stories, it's still okay.
It is possible, yes. You need a good static person who can calculate the static parameters. But even up to 8 floors is possible. The base floors, ground floor, first floor, will have AC blocks with very high density. Up to 700 kilogram per cubic meter. And then on the higher floors, you can use a lower density.
But for the ground floor, we must have the beam rate.
You have the, let's say, the foundation going down.
We cannot the building by using this kind of block on the ground directly. We need the foundation, holes to get into the ground to, especially with the for the first floor, we have to have the ground beam, and then we
have the concrete plate, and then we can just put the stones on. As you can see on the picture, the whole house, 1-2 floors without any problem.
And this block can use as a slab also, or use as just a wall.
The blocks can be used for making outside walls, inside walls. The panels 6-meter long panels, reinforced or non-reinforced, with a metal mesh inside.
You mean the wall panel?
Can be used for outside walls, yes. And without the reinforcement, you can use them for partition walls inside the building with the same parameters like the very good thermal insulation, fire resistant.
But cannot be used as a slab.
We can also use it for the flooring instead of the big concrete slabs you normally use, which are very heavy, difficult to handle. The 6-meter AAC panel floor slab is much easier to carry. Maybe with 2 employees you can carry it up. With a concrete cement slab you need a crane to carry it up. Flooring is possible, partition walls is possible, outside walls for factories, storage areas, all this is very is possible and also very time-saving erection of the buildings.
And how about the situation of this kind of material in Thailand so far?
Definitely AAC is getting more popular. It's still growing.
In Monbao.
But still as a small block replacing the red brick. The prejudices, the thinking against AAC is still quite common. You hear people saying, oh, but if you use AAC, termites will come and eat it, which is completely wrong because this is a completely natural material, so termites will never go on a natural stone, yeah?
That might have nothing to eat then, AAC.
Yeah. So you will still hear a lot of people saying something against it. Oh, it's too weak, it's not good with water, it's getting green from the outside when it's grown.
Yeah, because in Thailand we are in the monsoon area. Yeah, we have many rainy. Yeah, this time during this time you see we have raining every day. And the problem if we use the wall with the AAC, and it will absorb water. And inside when we paint, if we do some painting, it will have a dam, and also the paint they will do like swell or something as well expel.
Exactly, one of the fears of people Asia for AAC, but with all the years of experience, we have not noticed any of these problems in the market yet. So the inside wall, the painting, the color will not get any problems, and
if it is inside wall, no problem. If it is the outside wall,
the finishing, the flustering, and then the paint should be normally enough protection for the wall. And even with a freestanding AAC wall, I have not heard of any problems.
And about the strength of the AAC, in Bangkok we have probably the subsidence or the settlement or the differential cement. And if we use the AAC, it's easy to crack. Because it's quite, in my point of view, it's quite brittle. I think it's brittle.
It really looks like, yeah. But I have seen a video where they let the AAC block fall down 10 meters on the ground. Nothing happened. It's still okay.
It's soft.
Exactly. So in there, concrete is full material. It's 100% concrete.
Okay.
So if there's something shifting in the building, the cracks will directly come in. With AAC, you have this beehive structure inside, which can compensate some movements definitely better. And most of the cracks you see normally are the plastering. The walls is something different than in this regard. With many buildings, when you see them built, after 1 year or 2 years, you see small cracks in the wall. And this,
but if it is not a small crack, if it's like a
wall
crack like that, I think it propagated from the wall.
I definitely would say it's more likely to happen in a precast concrete wall than in a AAC wall.
What is the advantages compared to the local material that we have?
One of the big advantages is definitely the thermal insulation.
Okay, thermal insulation. I see. I agree with this.
Fire protection.
You have a research for that?
There are a lot of researchers and official regulations, and especially Europe, Germany, they have regulations for everything. So there's a lot of information about this available. Yeah, the money saving in the construction.
Money saving, the cost saving.
Definitely one of the biggest points if you do it in the correct way. It is light. It saves the environment by creating up to 5 cubic meters out of 1 cubic meter of raw materials. So less cement consumed for the same amount of construction material. Less energy in the production side.
Green
is what is coming now. Yeah. And let's say better thermal insulation. The inside of the building don't have to be, let's say, cooled down that much, which is giving a well feeling for the people inside the building. Air cons always seems to make us sick. All these office buildings, when you sit under the aircon duct, you're the one wearing a jacket and a pullover and maybe gloves, because very cold air coming through this vent. 3 places further, the people are starting to sweat, but the one under the aircon getting the cold air all the time is not feeling well. Is getting sick often, not feeling well. If you can keep a building inside with a very nice temperature without influencing it too much, there are ways of water hoses going through the walls, making an indirect cooling of the room. All the tests show that people working in such an office are much more healthy, feeling much more healthier than people sitting in an office with an aircon getting all the time the cold air in. So already from this point, the thermal insulation is a very important factor. Energy, definitely. Energy cost.
Okay, energy saving.
Energy saving.
I mean, in terms of the production of this kind of material when compared to
and your aircon don't have to work that hard. If you have a house, if you build a house with AAC walls and you go in, no aircon, nothing. You go to the outside, you go to the inside, you already feel it's cooler inside.
Like we are in the cave.
Exactly, yeah. And then when there's water running down the wall of the cave, it's feeling even more cooler.
Okay.
So the evaporation of the water is having a very nice cooling effect. But the hot air will stay outside, the cool air will stay in. So you have less aircon working to keep the air in the right temperature inside. And this saves you every month cost on your electricity bill.
Okay, I see. ครับก็ท่านผู้ชมวันนี้ก็ได้พบกับคุณโรแลนด์นะฮะได้มาพูดให้ฟังเกี่ยวกับเรื่องจัดว่าเป็นอิฐมวลเบานะครับ AAC ก็ได้รับความรู้มากมายนะครับว่าอิฐมวลเบานั้นก็มีที่มาที่ไปอย่างไรมีการผลิตกรรมวิธีอย่างไรมีองค์ประกอบนะของเนื้ออิฐอย่างไรนะทำให้เกิดรูพุนได้อย่างไรแล้วก็ได้พูดถึงข้อดีมากมายนะครับของการใช้อิฐมวลเบานะครับแต่อย่างไรก็ตามเราก็คงต้องเปรียบเทียบกันนะครับเพราะว่าในบ้านเราเองเนี่ยเราก็มีอิฐที่เป็นอิฐพื้นเมืองที่เราใช้อยู่ที่เราเรียกอิฐแดงแล้วเราก็มีอิฐบล็อกอิฐมวลเบาก็เป็นผลิตภัณฑ์ที่เข้ามาระยะหนึ่งแล้วนะครับเราก็ได้รู้จักกันในระยะหนึ่งแล้วเพียงแต่ว่ายังไม่เคยมีใครมาเล่าให้เราฟังถึงที่มาที่ไปนะครับวันนี้คุณโรแลนด์ก็มาเล่าให้เราฟังนะครับเดี๋ยวจะให้หมายเลขโทรศัพท์ไว้ด้านล่างนะครับนะเผื่อใครสนใจที่จะติดต่อนะคุณโรแลนด์ทางคุณโรแลนด์นี้ก็เป็นบริษัทที่ขายเครื่องจักรนะครับที่ผลิต AAC แล้วก็ถ้าบริษัทใดที่มีเครื่องจักรอยู่แล้วแล้วต้องการที่จะทำให้มันทันสมัยขึ้นปรับเปลี่ยนระบบก็สามารถติดต่อได้นะครับคิดว่าผมคงจะสื่อความได้ตรงอย่างที่คุณโรแลนด์บอกนะครับครับก็อย่างน้อยวันนี้ก็ได้รับข้อมูลนะครับเป็นอีกเรื่องหนึ่งนะที่โยธาน่ารู้นำมาเสนอก็คลุกคลักบ้างนะครับ ครับสำหรับวันนี้ก็สวัสดีนะครับอย่าลืมนะครับกดไลค์กดแชร์กด subscribe นะครับให้กับเราด้วยนะครับแล้วก็อย่าลืมช่วงนี้ก็ยังมีการระบาดของไวรัสโควิดอยู่ก็ปิดจมูกปิดปากนะล้างมือทำความสะอาดให้เรียบร้อยเพื่อที่จะได้ปลอดภัยนะครับสำหรับวันนี้ก็สวัสดีนะครับเรียนพิเศษ Goodbye to you สวัสดีนะครับ
ครับสวัสดีครับ
ครับ